Thank you so much, Dr. Ajay. I feel really honored to be able to present today. So thank you for inviting me. When we first communicated, I thought a little bit about which topic to choose. And you said there might be some complete beginners, but I thought, what can I contribute? So admittedly, it's a bit more of an advanced topic. So I want to motivate you and show you how much you can achieve in R from very few lines of code. And I want to tell you two small anecdotes to that. The one is, when was my first contact to R? That's quite long ago, in 2007. I was working for a small company, and we produced a lot of cross tables, and we used SPSS, which is a license fee software, and we thought maybe we can avoid these license fees and use R instead. And they sent me to a weekend workshop, and it was so successful that after the workshop I said, I never want to open the software ever again. And I kept at that for 7 years, and then about 10 years ago, a little bit more than 10 years ago, I started my second attempt using R, and then I really got stuck and caught fire, and now I don't want to miss it, and I enjoy it very much. You might think, okay, if R has been around for so long and getting into R now is quite late because so much has been done over the last couple of decades already. But I'd say on the contrary, it's a very good time to get more into R because a lot of development goes into making R more user-friendly and more accessible. And there are a lot of high-level packages that allow us to do great things from very few lines of code, and this talk shall contribute to that a little bit. So for those who are new to R, don't worry too much about the details of the code, and maybe try to focus more on the big picture and see that it really doesn't take much programming, and you can achieve a lot from very few lines of code. The second anecdote, I once taught a workshop for Java programmers, and they were a bit skeptical. They said, we love Java, and we're convinced we can do anything we like with Java, but now we're forced to use R, so we're not sure about R yet. And then the workshop went on, and at one point they got these huge eyes, and they were really intrigued by R, and they said, we can do this in Java, and it takes us at least 1 or 2 screens full of code, and in R it's just 1 line of code, so that's great. And then they really got caught into R. Okay, so much for the start. By the way, the slides that I show here, I have a presentation that I can send you after the session, and also the code. I have a separate R script, so I can send that to you as well if it's too fast now during this session. I try to keep the chat, an eye on the chat, but if I miss any urgent questions, you are welcome to interrupt me anytime. But I hope we also have time at the end to discuss a bit. So let's start. The data that I prepared for these examples today focus on music. So I hope you're interested in that a little bit. Chart music, songs and albums. We'll focus on albums today. So I have 2 data sets about chart success of musical albums. The first data set that we use is called Albums 2000, and it contains albums since January 2000, and it has the top 50 albums for each month. So that means that one album can appear several times in the data set if it stays in the charts for several months. So we can examine how successful different artists were in placing albums in the charts. And to this end, I created a chart, a graphic. We'll get into the code in a moment. And now we could think for a moment about why should we work code-based in the first place. I don't know about your background, so if you like, you can write in the chat. Whoever has access to the chat can do that. Of course, if you are familiar with other tools, you could create charts using Excel, or Microsoft Excel, or maybe Tableau or other software, and you don't need to know how to code. So for a single graphic or chart, this might be convenient, but imagine we want to do a similar chart to this one, but not for the year 2020, but for other years as well. And then we would have to repeat the steps to create this chart for each different year. And working code-based, we can automate this process a lot more. So here's some code. So for those who are new to R, don't worry too much about the details. I think today, in the age of artificial intelligence, we can come up with code like this with not too much of an effort. We can use help. Let's just focus on the big picture. So I worked out some code to create this graphic. But the question is, what do we do if we want to do more similar charts like this for different years, or more generally speaking, for different subgroups of our data? Of course, we could use this code block that we have and copy and paste that, and then just adjust the details that we need. So if we focus on just the year 2020, it appears in two parts of our code. So at the beginning of the code, I filter for the year 2020 to create a subset of the data just for this 1 year. And a bit further down in the code, there's a code line that creates a title for the chart and that puts the year 2020 in the title as well. So if we wanted to create the same chart for different years, we have these two parts in the beginning where we filter for the year, and for the title where we would have to change the year or the date to create a different chart. So as I said, the easy way would be to use copy and paste. That's quite quick and doesn't take programming skills, and we can just change the year 2020 maybe to the year 2019 if we go back in time, and repeat that until we have all the code we need for different charts. But now imagine you create all these charts and then someone comes along and says, maybe we need to change the style a little bit, use different colors, use a different background, use a different theme, a different style, whatever, different font sizes. We would have to make these adjustments in many parts of our code, and that is not something that we would like to do as a programmer. So there's this programming principle, dry, not as the opposite of wet, but as a shortcut for don't repeat yourself. So this is something we should strive for in programming. We don't want to write repetitive code, but we want to keep it as short and concise as possible, so that if we have to make changes, we make them in one part of the code only. And to achieve this in R, we can write functions. So R is very much focused on using and also writing functions. We can call it a functional programming language. So going back to the code, let's say we came up with this code slice, with this code block, maybe with help of artificial intelligence, and now we want to turn that into a function. And that is not rocket science. It's not as hard as it may seem. You see here we have 14 lines of code to create this particular chart. And turning this into a function is just 2 extra lines. And we have this first line of code where I define this whole block as a function. And at the end, I have to close this curly brace. So I have to just wrap this code into a function definition. So that's not very complicated. And there are 2 more changes. I don't know, those of you who are very, very quick have maybe already seen it. The function takes 1 parameter, the year. We want to create this chart or diagram for different years, and we have to make the code more flexible. In the first part, maybe you remember that the number 2020 was hard-coded, and now here we have year as a function parameter. So there are 2 lines of the code here in the beginning where we say the function takes the parameter year, and then in line 3, we use the year to filter the data, so it's more flexible than before. And also further down where we create the title for the chart, we put in this parameter year rather than the hard-coded number 2020. So once we have done that, we have a function. And now don't get drawn up too much on the left side where we repeat the code for the function, but rather focus on the right side of this slide and see the beauty of this code now. I want to create 2 more charts for 2 different years, and now I can just say my plot, the not very creative name I gave my function, my plot, and I just use that and paste the year, and I get a chart for that year back. So that's very simple. and then again for the year 2018, and I get another chart. And you see it's the same style, but different contents, different bands, different numbers. So the data gets filtered and we get this chart. Now we can take a deep breath and just maybe enjoy the beauty of this simple code that we can now use to create different plots. But maybe it's not perfect yet. So imagine it's not just 2 or 3 charts that we want to create, but maybe in my case, it's 21 charts that I want to create from the year 2000 all the way up to the year 2020 for each year. So I would have to write 21 times my plot and then provide the year. So there's still a bit of redundancy, and we can make it even more elegant. So the right-hand side, I think, is already much better than using this copy and paste approach. Yeah, but as I said, some redundancy still if I have to create many charts. So we want to get even more elegant, and we can create many charts, in my case 21, but it could be any number if you have bigger data with more subgroups. So we can do that in base R, and it's a very simple code, a very simple one-liner, just passing the years. So the colon here in this code doesn't mean divide by, but it means to. So from 2000 to 2020, and we call this function myplot using lapply. And from this simple one line of code, we get 21 different plots. So yeah, this is quite a concise and simple code, I think. I have RStudio prepared, so if you like, I can also show it live in RStudio. I would maybe now like to go through the presentation first to give you an idea of what we are doing, and then later we can dive a bit more into the code if you like. So for this first run, I would keep it a bit shorter, and then we can take a deep breath and then look into the code a little bit more. So we boiled it down from a lot of lines of code that we might repeat using copy and paste workflows to just one line for many plots. There are some tidyverse versions that are similar to that. I can show you that now. The difference is not very big. So lapply is a base R function that you can use without installing any additional packages. But for the chart itself, we have already used tidyverse functions, so we have the tidyverse available as well. Map is like lapply, basically, a bit shorter, the function name, but it does the same. And now I show you live. It's maybe more intriguing. So I ran already some preparatory code. We have this RStudio overview here. And in the bottom right, we have room for the plots. So it says plots here, and it's empty at the moment. And now I run this one line of code. I have defined my function before. And you see it takes a few seconds, but not many. And now we have these plots in the bottom right, and I can navigate here using the arrows and click backwards, and you see that we really have these plots, 21 plots, all created from this one line of code. So this is the beauty of functional programming. Maybe if you paid close attention to the RStudio console on the bottom left, you see that there's also some output here. We have these double square brackets and the numbers from 1 to 21, denoting the 21 charts, plots that we created. But there's no output in the console because the plots are on the bottom right in a different window, in a different pane. So this lapply returns a list, but this list is empty because our return value is the plot. So if we even want to get rid of that, we can use a tidyverse version of lapply that is called walk. The syntax is a little bit different, but don't worry too much about it. It just means that we want to get the plots, but we don't want to have any output in the console. So once again, to show you that the plots are created, I delete the plots and run this walk function instead of lapply or map. And now you see that we have no output in the console, that could be more convenient when you create a report, let's say, and you don't want these outputs as part of your report. So again, we have these 21 plots, but now the console stayed silent. And the last version of this function that I want to show you is if you have calculations that take more time and you want to assure your user that the computer hasn't crashed, you can also include a progress bar. So it's very simple. In tidyverse, you just have to add this .progress equals true in the walk function. This is not included in base R so easily, so the tidyverse gives us this option, and now you see in the console at the bottom left that the progress bar appears. It was quite quick now because these few plots don't take much time. I run it again. In the bottom left, you should be able to see for a few seconds at least the progress bar. So you might use this for more long-running calculations, and then the progress bar will be even more useful. Right, so this was a very quick run through the first example. As I said, don't worry too much about all the details of the plotting code and maybe focus more on the big picture and see that using a function can be so simple that you can get a lot of results just from one line of code. Are there any direct questions about this part? Or maybe if not, I would show you the second part first, and then we will have some time to discuss and maybe look into the code in more detail, and you can ask more questions. So there are no questions in the chat at the moment. So we can take a deep breath and then get ready for the second example. The second example is about statistical models. I will keep the statistics part very simple so that we can focus more on the programming side and again see how we can get a lot of results from very few lines of code. It's more than one line of code now, but not more than 4 lines that we need. So here I use a different data set for this example. The data that we had before had several entries for one album if that album stayed in the charts for more than 1 month. The data set that I use now is different. Each album appears only once with some scores. So here we see, for example, scores for the US and scores for Europe, and a year of publication and album title and name of artist or band, of course. And we have a total of 3,000 albums in this data set. And my idea is I want to create statistical models, but before I do this, I show you a little cartoon just to lighten up a little bit about programming techniques. Maybe you can relate to this. On the left-hand side with this magic cube, you see the ideal situation, maybe coding as we learn it in ideal surroundings. Everything is solved perfectly. And on the right-hand side, it's more like a workaround. It's solved too, but maybe not as elegantly. So maybe you can relate to that. And of course, we want to learn techniques that leave us more on the left-hand side, programming elegantly as it should be. Okay, so let's dive in. I created a little chart to make you a bit more familiar with the data. So we have different bands or artists, and here I show just the top 4 with the most albums in the top 3,000. So we have Bob Dylan, Elton John, the Beatles, and the Rolling Stones. It's a bit focused on older bands and artists, as you see. They were quite successful in terms of staying in the charts for longer than it is common today. And I split this data now in such a way that I only select artists or bands that have at least 10 albums. That's not much for statistics, but it gives me 47 albums or, 47 bands or subgroups in the data. And I want to create one statistical model for each of the 47 subgroups. And my idea is a very simple model that says if I know how successful an album is in the United States, can I predict how successful it will be in Europe? So I just have one predictor, the score in the US, raw score, and one result variable, the score in Europe. And examining the data a little bit, we see that this relationship between the two variables is different for different bands. So some bands are successful both in the US and in Europe, and some bands are only successful in the US and some bands are only successful in Europe, and the relationship differs quite a lot between different bands. So I don't want one general model for the whole data set, but I want a separate model for each artist or band. And remember, we have 47 different bands in this data set that have at least 10 albums. So that's quite a lot. So the usual easy way, or easy in terms of no programming knowledge required, but it gets complicated very quickly, would be to filter the data manually for each subgroup and then create a separate model for each subgroup. If you just have 2 or 3 subgroups, maybe you can get away using copy and paste, but for 47 different categories or subgroups, it would be quite inconvenient to split the data manually. So we want to see a more elegant way. And also the question is how we can process the results. From what I heard, you may not have created statistical models in R. That will come, I'm sure. When you start doing statistical models in R, you will find some functions that produce output in the console. And now imagine getting output for 47 models in the console. You wouldn't like to go there and copy and paste manually some results like R squared or coefficients and put them in some report, PowerPoint or Word document or whatever you use. You wouldn't like to do that manually. So we want to have a format that is more elegant and easier for post-processing so that we can compare models across subgroups more easily. Okay, so now get ready for a solution. We will break it down and take some time to look into it, but it's just 4 lines of code that do a lot of work for us. And I show you these 4 lines now. Don't get soaked up too much in the details, but just see how short this code is. So, and 1 line of code is just specifying the data set. I could even boil it down to 3 lines of code, but then it would be a bit harder to read. I start with the data set, and then I have 3 functions, and that's all I need to get results for 47 different groups, or it would work in the same way even for larger groups. If you really have big data with more subcategories, it would be the same technique. So we have 3 functions. One is nest by, one is mutate, and one is summarize. So nest by prepares the data, and we'll see in a moment what that looks like. Mutate creates the actual models. So you see this model formula in here with the raw scores that we want to predict. And summarize prepares the results for us in a way that we can look at them conveniently. So these few lines of code are enough to print the table that we see at the bottom. I limited it just to 3 bands for the sake of the slide, but I could display 47 bands or subgroups in the same way. So you see that we have a table, it's called a tibble here, that we can present in a report, and we have some statistical results like the R squared and some other overall statistics for the model. I don't want to get too much into the statistical details here, but maybe you can just see that the R squared, which is one result of the linear model, is neatly placed in this column, and we get all the subgroups in one column. So we could sort by the R squared and compare models very conveniently without using any copy and paste or without manually assembling results that are spread out over different result tables. Yeah, that's basically what I wanted to show you. And now I would just go a little bit into details what these lines of code do. Again, if you're a complete beginner, don't worry too much. You shouldn't be able to reproduce this immediately from scratch after the presentation. My motivation would be to show you that you don't need to write much code to get powerful results, and hopefully that motivates you to find more fun using R. So just looking at these 3 functions that we want to compare now, nest, by, mutate, and summarize, I show you a little bit what they do, and after that we can start the discussion and maybe go more into the code. So the basic trick, instead of creating separate data sets in separate objects as we might have done, not knowing this programming trick, we can just use this nest by function. And here I break down each step separately, so we see the result of this nest by function. And before we had several rows of data for each band if they had several albums. For example, AC/DC have 16 albums in this data set. And now we get a different data set that is prepared for the analysis that we want to do, that just contains one row per band. And then it contains this dubious column called data. And this column contains the subsets of the data, the different data sets, we can say. So you see, instead of a single value as we are used from other applications, we see this 16 times 8, which means we have 16 rows and 8 columns. So each row, each cell in this data column contains a subset of data. So we don't have to manually filter for all the bands that we're interested in. We just use this nest by function, and then we have the data prepared for the further steps that we want to apply. Don't worry too much about data, even using basic or tidyverse, like simple R functions. You can work with this data. We won't follow this approach here because we just use the next step to process the data further. So after nest by, the second step is the mutate step, where we create the model. So I have the model formula here. And this one line of code creates for each subset of the data the model that I'm interested in. And you see at the left column bottom, we get a new column called model. And here it just says LM. So in this view, we don't see the details. We just see that a linear model has been created for each band or each subgroup of the data separately. So no loop, not much programming effort is made, just one line of code. And the data that we prepared before using nest by is now processed so that we get all these linear models in one short step. Again, it is possible using some base R or tidyverse functions to access this data, to access these model results, but that's not very convenient. We want to use a convenient function, and that is in the Broom package, which is part of the tidyverse collection of packages. So again, just one line of code and one function from the Broom package to summarize the results. And then these LMs that were hidden here in this model column are now prepared so that all the different values and performance measures are extracted from the model, so that, for example, we can compare the R-squared values. And we see this relationship between the two variables that we are interested in differs quite a lot between different bands. If you take the R-squared and you compare AC/DC to ABBA, the difference is quite huge. So for some bands, the relationship is quite strong between these two scores in Europe and the US, and for some bands, the relationship is very weak. Right. So I don't know if any of you are a little bit into statistics. You might say, okay, R-squared is nice to have, but there are also individual coefficients for our models, and we don't see them here, and that's true. So there's a different function that we can use alternatively. Glance that we have used here gives us this model overview with some overall statistics like R-squared. And the second function is called tidy, fitting to the tidyverse, tidy up results. You can do that in base R, but it's not very convenient. With this tidy function, it is very convenient. And now you see that we get different results back, and now we get the individual coefficients that are called estimate here. So we have 2 rows per band or per subgroup in this case, because our model has 2 coefficients, one for the intercept and one for this predictor scores in the US that we have. So a very convenient way to prepare these results. Yeah. Right. That was maybe a lot to process, but this is already the key of what I wanted to show you. So just to finish off, the second last slide, apart from the, no, I have two more or so, but maybe we can just take a deep breath and get back to this line of code that shows these three functions as an overview again. So yeah, I hope I didn't scare you off too much and you are not too much worried about the details, but rather see the beauty of writing very short and concise code to obtain a lot of results. If that is what you take away, then I would be very happy. And maybe I take a break now and we can talk about it. You can ask questions about the code or other questions. And if you like, I also have our studio ready so we can work more with the code if you like to do that.